Think math.
If the terms keep shrinking, must the sum eventually settle? A half plus a quarter plus an eighth settled at 1. So what about 1 plus a half plus a third plus a quarter? Here too the terms shrink, and in the end they shrink away to nothing. And yet this series runs to infinity, shrinking and still never settling. How can that be? Here is the trick Oresme found 700 years ago. Gather the later terms into blocks and push each block downward. A third plus a quarter. Both are at least a quarter, so the block is at least a half. The next 4 terms, from a fifth to an eighth, are each at least an eighth, so again at least a half. The 8 terms from a ninth to a 16th behave the same way. Every block we form is at least a half. And these blocks never run out. Next comes a 17th through a 32nd, then a block twice as wide, and so on forever. Every block contributes at least a half. So the whole series is larger than a half added over and over without end. Adding a half endlessly clearly runs to infinity. So the partial sums pass any number you care to name. The series diverges. The growth, though, is remarkably slow. 2 terms give 1.5, 4 terms about 2.08. 8 terms reach only 2.72, and 16 terms 3.38. To pass 5, you need more than 80 terms. To the eye, it looks as though the sum is settling somewhere. That is exactly why we trust the blocks, and not the eye. Out of this comes an important lesson. Terms shrinking away to nothing is only a necessary condition for convergence. If they do not shrink away, the series certainly diverges. That much is safe. But shrinking away does not guarantee that it converges. The harmonic series is the counterexample. So never judge by the terms alone. Watch what the partial sums do. To sum up, the harmonic series diverges even though its terms shrink. Gather the later terms and every block is at least a half, and those blocks never run out. The geometric series settled because its terms shrank fast enough. Not whether they shrink, but how fast they shrink. That is what decides it. This question is the starting point for every convergence test ahead. A sip of math, every day, here at Think Math.